So next in this section, we're going to look at how two events interact. There's two basic ways that they can interact, and you can calculate the probability of the interaction between two events. So first, we're going to look at the intersection of two events. So what is that? So the outcome of an experiment is within the intersection of events A and C. So typically when you see two events, and we're talking about intersection, we'll use the word and between them, or we'll use what looks like a capital upside down U. Okay, that stands for intersection. So down below here, we've got two examples, one with two events, A and C, that are not overlapping. When you've got two events like this that are not overlapping, we call that disjoint or mutually exclusive, but we'll get into that a little bit more. And here we've got, on our second example, events A and C such that their Venn diagrams of those two events are overlapping each other. And whenever you've got two events that are disjoint, meaning they're not overlapping, then the order of their intersection is going to be zero. It's zero because they don't intersect. So there's nothing in their intersection. Whereas by contrast, when you have two events that intersect and they are not disjoint, meaning they do have some overlap, then their intersection will not be zero. There will be something there. Okay, that's kind of what I mean by that. So in a Venn diagram, the intersection of two events are where the bubbles of both events overlap. So it's common to shade in areas of interest in Venn diagrams. And so here I've got, notice the area shaded is in the area overlap between events A and C. So what I would do is I would say right here is A intersects C, and it's this area right there, where we have an area of overlap between those two events. So let's look at an example of a Venn diagram of dolphins, fish, and their properties. So we're going to let event A be composed of dolphins and their properties. So here you can see we've got event A, which is in green. Dolphins have flippers, which are a bony structure. Dolphins have lungs. Dolphins are warm-blooded, and they also have live births. And then we're going to let event C, use a different color here. So event C is going to be fish and their properties. And so fish have fins, which are composed of cartilage. They have gills for breathing. They are cold-blooded, and they lay eggs. Now you'll notice that this event A, which is dolphins and their properties, and event C, which is fish and their properties, they overlap. So what's in the overlap between these two separate species? Well, you'll notice that we've got lungfish overlapping these two subsets. And that's because lungfish are fish with both lungs and gills. So they have this property of dolphins, they have lungs, and they have this property of fish, they have gills. So they're in this space kind of in between both dolphins and fish. An OPA, okay, which is right here, also in that intersection, is the only fish which is warm-blooded. So most fish are cold-blooded, but an OPA is kind of sharing a little bit in the properties of dolphins, and that dolphins are warm-blooded. Well, so is an OPA. So an OPA technically is a fish, but it's a fish with a similar property to dolphins. So when you've got, some overlap between two events, we kind of express that with the area of these two bubbles, which represent the two events, kind of intersecting each other. So let's take this idea of intersection to extend this a little bit more towards calculating probabilities of things. So here in this example, we're trying to find the intersection of two events. Okay, we're just finding the intersection. We're not calculating any probabilities yet. So we're going to let event A be outcomes of a six-sided die, which is going to be 1, 2, 3, 4, 5, and 6. And we're going to let event B be outcomes of a two-sided die, which is going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So let's create a Venn diagram of these two events. So let's see here. Event A is going to have 1, 2, 3, 4, 5, and 6 in it. Okay, 1, 2, 3, 4, 5, and 6. And let me go ahead and circle that like this. And event B will have 2, 3, 4, 5, and 6. All right, it's going to have those elements. And then 7, 8, 9, 10, 11, and 12. And that is event B. And then we'll go one step further and we'll create a sample space kind of around both of these, like that. All right, so here we've created a Venn diagram of events A and B. Now, what is the sample space of all possible outcomes? Well, it's going to be everything from 1 up to 12. So the sample space is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And what outcomes are in the intersection? So what is A intersect B? Another way we could write this is A and B. Well, the intersection between A and B is going to be this area where they overlap. And what we've got are 2, 3, 4, 5, and 6. And we could just take this one step further and just ask, what is the order of the intersection of A and B? Oh, there's 1, 2, 3, 4, 5 elements in the intersection. So the order of the intersection is 5.